Okay, so once again, remember to hit record when you're making a video. This is going to be on covalent compounds. We already did ionic. And there are a couple other videos about how to draw covalent molecules. We can use the term molecule when talking about covalent. So let's take a look at our periodic table real quick. Remember, we always had these oxidation numbers that are associated with the columns when it came to ionic. Not the case with covalent. Also remember that this left side of the periodic table in the middle are all metals. Okay? So when we talk about covalent, and if you recall previous notes, covalent only deals with nonmetals over here on the right side. And you can see there's a very small amount. So this is the noble gases. Noble gases are neutral. They are also stable, so they do not like to bond with anything else. Okay, so if we eliminate those, we're talking about an even smaller section here that we're going to be dealing with. Okay, so you're going to see the same elements pretty much over and over again. Once again, we do not deal with oxidation numbers. Remember that the electrons are being shared, not given up or received. So here are the notes. Remember, we do not crisscross. It's very important. We are using two non-metals on the right-hand side. So if you're ever looking at a compound and you're trying to figure out if it's a covalent or an ionic, one, if it's a word, look for prefixes. If it has prefixes, it has to be a covalent. Also, if there's a non-metal starting out, well, basically two non-metals, it has to be covalent. Okay? So first off, we use this prefix system. First element gets a prefix unless it is only one, and we'll show an example like that. And the second one always gets a prefix, and just like ionic, we change it to IDE. This last one could be a little tricky. Okay. O and A of the prefixes, not the oxide. They are dropped when attached to oxide. Okay. Now here are our prefixes. If and when we would have a test on this, you'd be required to memorize these. Sometimes it's a little bit easier to memorize certain ones because, like, I played the game Tetris a lot growing up, I guess, and not too long ago. And Tetra is all about getting 4 lines at the same time. Okay, so there you go, 4. You get more points that way. Octopus, where does that come from? Octa. Okay, and so on and so on. Some of them, like 9, I have a hard time remembering a lot of times. So it's going to require maybe some practice on your part, some memorization, but there's only 10, and some of them are going to be pretty familiar. Okay, so now we're going to do some examples. I already wrote them here, but I didn't hit record, so I'm going to do them again. I'm going to just do them on this sheet on top. So first off, example 1. Now, when we do these, remember, when we had ionic, we would just say like sodium and chlorine together, and you'd figure out what the compound was. When we do covalent, you're going to be given the compound, okay? And you're either then going to have to draw it and name it. Okay. So here's our first one, carbon and iodine. 2 nonmetals, both on the right-hand side, up in that little corner. Carbon only has 1, so following our rules, we only write carbon. We don't put monocarbon, okay? And then there's 4, so that's tetra. So we do tetra iodine. Well, if you remember the notes, we change it to IDE. Tetraiodide. Sounds kind of weird. So the nice thing about these in the ionic is we change those endings to IDE when they're just by themselves, like they're not a polyatomic. Remember too that there's going to be no polyatomics in these because those are polyatomic ions. Okay. So that's the first one. Example 2. We have astatine 2, selenium with 3. So 2 is di. So we have di astatine. And then we have 3 sulfurs. So it would be what was sulfur? Sulfide, yep. Okay. There's our first couple. Now we'll do these, and it has the oxygen in there. There's that oxygen rule, right? We drop the O or the A if we pair it up with oxygen. So the first one, phosphorus with 4, oxygen with 10. So 4 is tetra. Tetraphosphorus. Okay, it's not tetraphosphide or anything like that. If it's the first one, we do not change it. We only put the word with the prefix. And then we have 10. So dec, we drop the A and we put oxide. Okay, you don't have to underline the prefixes and whatnot. I'm just doing it so you could see it. Okay, so it's not decaoxide. I actually looked online and it was like an or next to decaoxide or decoxide. But we are going to follow the rule that we drop the A when it's paired up with oxygen. And now example 4. Hopefully it fits in here. Slide it up a little bit. And it's SeF6. So Se is selenium. We don't put mono because we do not put mono on the first one if there's only one. But would we put it on the second? Absolutely. And then we would have fluoride, but we have 6. So it's hexafluoride. And we don't have anything here because we don't put 1. Okay. So I'm just going to make up. I'm just going to make up one, okay? Just to kind of prove a point. Let's say we had like P2S. Okay? Now I'm not saying that exists, so don't act like it does. So we would do diphosphorus. And we only have one sulfur. So we actually put mono sulfide. So over here, when we had 1 at the beginning, we don't put mono. But if we have 1 on the second element, we do put it. Okay. So there's about 5 quick examples. Now I'm going to do examples where you're given the name and then you just have to write it out. Actually, these are a lot easier, if you ask me, than ionic. So for this one, we're going to do name to compound. Like the chemical compound, H2O, that sort of thing. Okay. So first off, phosphorus trichloride. I'm just going to go ahead and write these out. Dinitrogen tetroxide. And then maybe you could even pause the video. silicon dioxide. Dichlorine heptoxide. You notice these two right here, like di, it ended in I, so we didn't drop anything, but hepta, we dropped the A again when it was on oxygen. Okay. So first off, phosphorus is P, and there's nothing else. It's not di, tri, whatever phosphorus, so it's P by itself. Chlorine is Cl, and it's tri. And that's it. So the nice thing is, as long as you know the prefixes, you should be able to write these out fairly simple, okay? The prefixes and the symbols. We should be able to write their chemical formula. Okay. And that word was, I couldn't think of it earlier, which is pretty bad. Nitrogen di, which is 2. Oxygen, so that's oxygen. And tetra, that's 4. Silicon, Si. Oxygen, O. So there's only one of these, but we have 2 oxygens. Now chlorine, we have di, so there's 2. Hepta, 5. So oxygen, we have 5. And it's pretty straightforward. So there's 4 examples of going from, I don't know if we could see both of these at the same time. Have them there all at once. We went from the formula to the name, and then